longer to get through the first little part than it probably will the examples, although the one of them is a little bit on the longer side. So reread the essential question, the I can statement to yourself. Oh, we were just reading the I can statements, huh? I started reading the paragraph. I'm sorry. All right. Noelle, can you read us the essential question? Perfect. Marilyn, can you read us the I can statement? All right. Did you guys start reading the paragraph? All right. So I want you to read all the way through, actually, that whole page. Look, there's no notes to take on the whole first page. Isn't that amazing? So read that whole first page. What I want you to concentrate on, kind of read it once and then read it a second time. And I want you to see if you yourself, because you're going to have to do this next year, right? You're going to go to a math class. You're probably going to have to actually open a textbook and figure out something in it. So I want you to make sure you can see if you can figure out where they get all of these substitutions in this formula. Okay, so I'm going to give you like 3 minutes to read through it, and then go back and make sure you really analyze that sequence of formulas there. Give you about 1 more minute to go back through. If you haven't looked at that formula yet, try looking through that. Okay, so we're working with arc length today, which remember is just like a chunk of the curve, right? How much does a chunk of the curve measure? The arc length formula we had earlier in the year is there. That's this first thing right here. So we're trying to apply what we know from earlier in the year to parametric equations, okay? So what we learned about parametric equations this last week was that dy dx is really, and it's kind of goofy, right? Because they did the slashy fraction, which I absolutely hate. But it's the same thing as saying dy dt divided by dx dt, Okay, so that's what they said right here. Problem is that we got some weird complex fraction now, and they're trying to simplify it. Okay, so this thing here could be rewritten as squared on the top, squared on the bottom. In order to, we need a common denominator. What's my common denominator going to be? Dx dt what? Squared. So in order to make that a 1, it would be dx dt squared. So do you see where this is coming from now? They skipped this extra step of making the 1, and they just put it all over the same common denominator. Okay. Then, and I don't know why they did that, because look at what they did in the next line. The next line, they basically broke it up, right, into, what did they do in the next line? They got the dx dt squared. They did some canceling somewhere, yeah. But it's not, I can't tell where they canceled. Dx dt, dx dy dt, because they've got the dx dt somehow came out of the denominator. Oh, because there's a dx dt out here. They canceled with that dx. So see this extra dx dt out here? That's where it came from. So they had an extra dx dt, and that ends up canceling with this in here. Okay, so let's figure out where that came from. They had, I don't know where that one came from. Oh, I know where it came from. So we had to, so see this dx dt right here, or this dx, okay? I can't integrate the dt without having a t in the variable of integration being the dt, okay? So what they did was they multiplied top and bottom in this line here by dt over dt. So that's where this piece came in. Does that make sense? We good? No? No. Okay, let me explain it again, okay? All right, so do we understand the fraction piece, where they got the fraction piece from? Okay, everybody's good with the fraction piece. Okay, so what we also have to add in is we're trying to turn our variable of integration into dt, not dx, okay? We know that we aren't going to change the equation in any way by multiplying by 1, all right? So I have to work with this variable of integration that's right there. So what they did was they multiplied by dt over dt, okay? Then they broke that up into dx over dt times dt. So they just manipulated that 1, all right? Then the line that got skipped is, so to get reduced back to this, they took the square root of this. What's the square root of dx dt squared? Dx dt. So I'm going to write a little line in here, okay? So I still have this mess, the dx dt squared plus dy dt squared, okay, over dx dt times the dx dt times the dt. So do you see how we have a dx dt, and they're both, one's in the numerator and one's in the denominator? What's going to happen? They're going to cancel, and now we're back to this line right there. Okay, so that's why that denominator went away, because it canceled with the dt, the dx dt that we brought in. Okay, and then another way to write it is it's the derivative of the f function and times the, or plus the derivative of the y function, and we square both of them. So that's the, you don't have to know how they developed the formula. It's there. It's good to look at. It's kind of good to stretch our brains a little bit. You just have to know the formula. Okay. So you're gonna have to, you're responsible for 2 arc length formulas on the AP test. You're responsible for this one, which was just rectangular, okay, and you're responsible for parametric. So really, this one here, it's just the square root of the derivative of x squared plus the derivative of y squared. Okay, that's all that it is. It looks like another formula though that we're familiar with. Do you guys know another formula that has an x squared, a couple of squareds in it? Do you remember this one? Or you guys probably learned it like this because you didn't have Mrs. Ballard for geometry, right? And then if I solve that, isn't this just, if I did the square root of both sides, It would be the square root of a squared plus b squared equals c. It looks very much, it isn't the Pythagorean theorem, but it looks very much like the Pythagorean theorem. Okay. So if you think arc length and go, oh, Mrs. Ballard said something about the Pythagorean theorem, I know I've got to square my derivatives on the inside. Okay. All right. There really isn't, they gave it to us in a couple of different forms. Arc length is distance traveled. Okay. So you just need to know that it's distance traveled. All right, this one is going to be stretching ourselves and doing some integration we haven't practiced in a while. Okay, so that's what we're going to do in example 1. I did give you the sticky notes just in case. If you write small enough, you'll probably be fine. I wrote way too big, so last year when I'm looking at it. So, all right, read the question to yourself. Okay. They would not have on the AP test this heading here. Okay, so you wouldn't see that. If that wasn't there, we know we're supposed to find arc length. How do you know you're parametric? There's a t. What else? You have an x and a y. Okay. Or they give you, they might, if they take the derivative for you, right, they'd have dx, dt, dy, dt. Okay. So you have to recognize the fact that you've got it defined parametrically. Sometimes they'll say it on the free response problem that it's defined parametrically. Sometimes they won't. But so if you don't say, it doesn't say it, state it, and you have the two things, you're going to make sure that you're just going to assume it's parametric. Okay. All right. I know for arc length, I've got to find some derivatives, right? So I've got to find the derivative of the x and derivative of the t. So let's do that first. So x prime of t equals, what's the derivative of t cubed plus 2? 3t squared. Good. And then y prime of t is what? Where's the 2 going to go? Or this 9 halves, sorry, the 9 halves going to go? In the front. T, I'm subtracting a fancy 1. What do I get? 7 over 2. Good. And then what happens with my 2's in front? They cancel, so we get 9t to the 7 halves. Okay. That was just the derivative part off to the side. That's kind of my scratch work. That isn't even really arc length, right? I just did that to get to arc length. While you're learning it, it does not hurt to maybe write out at least the formula for or apply the formula to your function that you've got there so you can start kind of memorizing it. In this case, what are my bounds? 1 to 3. Very obvious, right? They gave us an interval. And then it's going to be the square root of x prime of t squared plus y prime of t squared dt. Again, that's just starting to that's helping you memorize the formula. Okay. You write it out something like that every time. And I know that seems weird to do on every problem. If you did it on every problem, you'd get it down. Okay. If you did 4 or 5 problems, you'd probably have it. Okay. So we're going to do this one by hand because notice there's not a little calculator by it because we're going to practice some of our old integration techniques here. All right. I am putting the 3t squared in. So we're doing 3t squared plus the 9t to the 7 halves squared. That's an exponent, not a multiplication. Okay. All right, let's simplify some algebra. What is 3t squared? 9t to the 4th. Perfect. We need to be a little bit careful on this one here. You want to make sure you square the 9. So what's 9 squared? 81. And then it's going to be t to the what? 7th. Good. Okay, we're going to see some weird algebra. It's always good for us to see weird things happen, though, right? So you don't know what College Board's going to throw at you. All right. I really don't know what to do to integrate that at this point, okay? A U substitution is not going to work, right? The U would have a t cubed and a t to the 6th, and I don't have that anywhere else in the problem. So I'm going to try to create it, kind of. I'm going to try to create my own U, or my variable on the outside. It looks like I have some square things in there, doesn't it? I've got a 9, I've got an 81, I've got a t to the 4th power. Those are all square things. So why don't I try factoring out a greatest common factor? Okay, so let's start there. So what would the greatest common factor be? What about the variables? 9 to the 4th. So remember, when you do greatest common factor with the variables, you want to pull the smallest exponent. Okay. All right, so this one would be 1 plus 9t cubed dt. Okay, so start thinking about that. If I took the derivative of 9t cubed, what would it be? What's my new exponent going to be? I'm gonna have a t squared, right? So I need to create myself a t squared somewhere on the outside. This is a square, isn't it? I'm going to rewrite it I'm going to rewrite it separately. You don't have to do this step. I just want you to see it maybe a little bit more clearly. Cubed, sorry. All right. Let's take the square root of that square. It's a square. We might as well take the square root of it and simplify. Maybe that will help us out. So it's the square root of 9t to the 4th. Oh, we were looking for a t squared, weren't we? Did we get it? Did we get what we wanted? Now I am ready to do a U substitution. Okay. So I'm going to use the inside as the U. We haven't done a U sub in a while, have we? Did all that series stuff and didn't do any U substitution. Hopefully you remember how to do it. AB gets to take their U substitution quiz today. Doesn't that sound like fun? All right. So du is going to be what? (27t squared). Perfect. All right. I'm going to rewrite the 27 as 9 times 3. That should help us. Oh, I forgot the dt, didn't I? Put the dt. Okay, so it looks like I have 3t squared dt. What am I missing? Got this piece. What am I missing in the du? Do I have that? No, I don't have that. I have it in orange. I can't count it twice, right? So I need to add that in. So remember, we add 1 on the inside and we do in 1/9 on the outside. On the AP exam, and you guys know this a little bit from last year, they never show a U substitution, right? If you're looking at like a scoring guide, you will never see it happen in a scoring guide. If you just put the 1/9 on the outside and you're working the problem, you're fine. Okay, if you happen to miss putting the 9 on the inside. Okay. They mostly expect you to just do the substitution. All right, so we're going to do the substitution. We are going to have the square root of u going in. And then for the 9 times 3t squared dt, we put in the du. Okay, there's one other adjustment we need to make. When we have a definite integral like that, what else should we really be doing? Look what I haven't written on my integral symbol yet. Yeah, what am I supposed to do with the bounds? These are t bounds, right? I need u bounds. How do I get u bounds? Yeah, we got to plug in here to u, don't we? Okay, so I'm going to plug the 1 in, and I'm going to plug the 3 in. So u of 1 equals 1 plus 9 times 1 cubed, which would just be 10. All right, and then u of 3 equals 1 plus 9 times 3 cubed. So 27 times 9, 223, and then plus 1, 244. Good. Hopefully they'd be nicer to you on the AP test. This one's ugly as far as that's concerned. Okay. How do I have to rewrite that square root of u in order to integrate it? U to the what? 1/2. Good. All right, I'm going to have to go over here because I'm running out of space. All right. So we've got 1/9 u to the what when I add my fancy one? 3/2 divided by 3/2 or multiplied by 2/3 from 10 to 244. And this is just pretty much pure ugliness. It's not going to be a pretty answer, and that's okay. It looks like if I simplified a little bit, I could get 2 over 27 u to the 3/2 from 10 to 244. And remember, because it's definite and I changed my bounds, I do not have to substitute the u back in. It's a shortcut. So at this point, to get a numeric answer, all I'm going to do is plug in the 244 and the 10. So 2 over 27, 244 to the 3/2 minus 2 over 27, 10 to the 3/2. There's nothing about, especially the 10 side, I don't know, maybe the 244, we can get something, but the 10 side definitely doesn't have anything I can do any fancy, like canceling with a base or any of that stuff. So I would just leave it. It's numeric. You're done. Okay. Really, the new stuff was in just setting up the integral, right? All the other stuff was old stuff. All right. We're going to do one more. Did everybody get it? I don't want to go too fast. Everybody good? Okay. We're going to find distance traveled. So take a minute and read that question to yourself. Okay, what are they asking us to find? Distance traveled. What does distance traveled mean we're going to do when we're in a parametric like this? It means arc length. It's a fancy way to say, hey, find the arc length of that thing. Okay. What did you notice about some of the symbols out here? What do we get to use this time? We get to use a calculator. Wasn't that nice of him? Because look at how awful that, especially this one. That doesn't look pretty. What do you notice about these things, though? Do we have the original equations? What do we have? They already gave us the derivative, okay? They're expecting you to mess up and take the derivative of it, okay? You need to recognize, again, where is the problem starting you? Is it starting you in the original? Is it starting in the derivative, the second derivative, okay? So where am I getting what are my bounds on my integral going to be? 1 to 2. Good. And then what's my arc length formula start with? Square root. Oh, My goodness. Okay, and I would probably, we're trying to practice this, so I would go into the context of the problem. Dx dt squared plus dy dt squared dt. And then I'm going to substitute in. So we would have this tangent inverse of e to the negative t, the whole thing squared, plus 3t over 1 plus 4t cubed squared. Okay. If this was a free response question, there would be more than one time you're probably manipulating the dx dt and the dy dt, which makes it a good habit to put it into the graph part of your calculator, okay? If it was multiple choice, you could just type it in exactly the way it looks if you really wanted to, okay? But that's a really complicated equation, so it might be, it still might be better to use our graphs. So let's go ahead and we're going to practice getting it typed in our calculator, okay? So I'm going to clear what I've got. And just for kicks, I'm going to put it in parametric mode because it shouldn't change our answer in any way. So I'm going to go menu, graph, edit, entry, edit, and parametric. If you forgot and you did one in F1 and one in F2, that's going to work for you too. Okay, so it doesn't matter. This gets you a graph of it, which maybe might be helpful on some part of the other part of the free response that we're not seeing in this particular item. Okay. All right. Oh my goodness. Apparently. Okay. So I'm going to go to tangent inverse. So that's trig. And the tangent inverse of e to the negative t. Okay. And then I want to control divide. And 3t over 1 plus 4t cubed. Once you've got it, hit enter. There it is. I noticed I was using one of the Inspire calculators, not my computer. My computer graphs it so fast I can't see it, but I did notice on your calculator, it's just enough of a little bit of a blip where you can see kind of the orientation. Okay, if you're watching really carefully, you can actually see it kind of graph in order. Okay, so you could have your little orientation arrows just by looking at it. All right, I'm back here. What do I have to do to get the integral? Shift plus 1 to 2. Square root, so control x squared. Ooh, that's not where I wanted it, is it? I'm going to come back down here. Control x squared. And then I'm going to do some parentheses. Var x1. Ooh. Oh, no, it is in derivative, right? So we don't need to worry about putting it in derivative. X1 squared plus var y1 of t. I forgot parentheses, didn't I? Squared and then dt at the end. Okay, 0.406. We all good? Okay. There is another problem there, but it is not something we are responsible for the AP exam. Okay. When you hit Calc 3 in college, it's gonna you will probably do the area of a surface of revolution. So what they're talking about here is it kind of envision like what a contact lens looks like. You would be finding the area of that contact lens using these formulas. Okay. So, but we don't have to do that. So it's one less we have to memorize. That's awesome. Okay. All right. That's it. I think I started putting the homework out there. Let me stop this thing here. And I will